Oftentimes, in many applications, it is necessary to decompose a vector into two separate vectors. Let's see what I mean by that. If v and w are two non-zero vectors, the vector projection of v onto w is given by v dot w over the magnitude of w squared times w. Then the projection of v into v1 and v2, where v1 is parallel to w and v2 is perpendicular to w, is given by v1 is the projection of v onto w, so that's the v dot w over the magnitude of w squared times w, and then v2 is going to equal v minus v1. One of the most common projections that takes place is where we decompose a vector v into a horizontal and a vertical component. So to give you an idea what's going on, we might take that vector v and write it as v1 is onto w, and then v2 is perpendicular to w. You should notice that v1 plus v2 should give you back v. So as an example, suppose we want to find the vector projection of v equals 1i plus 3j onto w equals I plus j. Then we're going to decompose v into two vectors v1 and v2, where v1 is going to be parallel to w and v2 is going to be orthogonal to w. Well, to find the vector that is parallel to w, that is the vector v1, we're going to compute v dot w over the magnitude of w squared and then times w. So v dot w is 1 times 1 plus 3 times 1 over the magnitude of w is going to be 1 squared plus 1 squared under the radical, but I got to square that result, and that's going to be times I plus j, so times w. So let's see what we're going to get. In the numerator I have 4. 1 plus 1 is 2. Square root of 2 squared is the square root of 2. So 4 over 2 is 2. So I have 2i plus 2j is v1. Then, to find the vector that is perpendicular to w, I find that v2 is going to equal the vector v minus the vector v1. Well, v is I plus 3j, and I subtract from that 2i plus 2j. So I minus 2i is negative I. 3i minus 2j is just j. So v2 is going to be perpendicular to w, and then v1 is parallel to w. Clearly that's the case because v1 is 2 times w, and if you computed the dot product of w and v2, you would get 0, which would imply that they're perpendicular. To help you visualize this result, we show you the graph of the vector v and the vector w, and then you can see v1 is parallel to w and v2 is perpendicular to w.